Please.
Thank you, President. Thank you for your introduction. And distinguished guests, ladies and gentlemen, good morning. It's my great honor to be here to introduce the work of CCT for the last 4 years and the thermometry for the next generation. As you all know, the thermometry measurement play a very important role in the sustainable society, such as monitoring the global warming and energy saving, and manufacturing and fair trade, as well as health and safety and research. All techniques and control process relies on the reliable temperature and humidity measurement. The Consultative Committee for Thermometry was set up in 1937. Now we have 24 members and 1 official observer. The last meeting was held in June last year. One of the key role of CCT is establishing and maintaining the temperature scale. Now it's ITS 90 and PLTS 2000. Issuing going from extremely low to high temperatures, humidity, and thermophysical quantity measurement, and the environment, and so on. As you know, the unit of temperature Kelvin now is defined as the 1 part in 273.16 of the thermodynamic temperature of triple pond water. You can find this definition still rely on the specific material, water. And from the talk yesterday, we can know the isotopic components of the water will give a strong impact on the thermodynamic temperature of the triple pond water. And also the isotopic components varies with the location. So it's the weakness of the definition. Recent years, scientists have already made great efforts for the redefinition of Kelvin. CCT play a unique and very important role to coordinate the redefinition work, the redefinition of Kelvin, by using Boltzmann constant instead of the temperature of the triple pond water. Many research teams have already made lots of the scientific research for the redefinition of the Kelvin with 4 primary methods. One is acoustic gas thermometry, which measures the speed of sound in the chamber, and the junction noise thermometry, which measures the electric noise on the resistors, and dielectric constant gas thermometry, which measures dielectric constant through the capacitance, and the Doppler broadening thermometry, which measures the spectral waves. So a lot of the resources have already been invested on this area, and a lot of measurement results have already been achieved for the last decade. Last year, CODATA accepted the measurement result of 3 different fundamentally methods: acoustic gas thermometry, and dielectric constant thermometry, and the junction noise thermometry. You can see the data here. Yes. And CODATA have already gave the new value of Boltzmann constant. The measurement results have already fulfilled the 2 conditions for the redefinition of Kelvin proposed by CCT, which is, number 1, the relative standard uncertainty of the adjusted value of Boltzmann constant is less than 1 part in a million. Number 2, the determination of Boltzmann constant is based on at least 2 fundamentally different methods, of which at least one result for each should have a relative standard uncertainty less than 3 parts in a million. In a sentence, with the groundbreaking work of the whole thermometry community, the criteria and conditions of the redefinition of Kelvin have been fulfilled. It's the right time to redefine the Kelvin. The redefinition of Kelvin lays the foundation of the future improvement, a definition of free material and technological constraints enable the development of the new and more precise temperature measurement technology, especially at the extremes of temperature. For the last several years, a team from CCT have already drafted the mise en pratique Kelvin, the practical realization method of Kelvin, including the ITS 90 and PRTS 2000 now we use, and the new primary method. With the support of this mise en pratique, the redefinition, after redefinition, we will have a less or no immediate effect on the temperature measurement practice and the traceability of temperature measurement. For the most of the users, it will pass unnoticed. After redefinition, the mise en pratique Kelvin will guide worldwide the dissemination of the Kelvin by primary method for the measurement, the thermodynamic temperature, and equally through the existing temperature scale, ITS 90 and PRTS 2000. That's the content of the mise en pratique Kelvin. CCT has its working group and task group on contact thermometry, radiation thermometry, humidity, thermophysical quantity, and the environment, secondary thermometry, and emerging technology. I would like to draw your attention to the working group on environment. As you know, having a precise temperature measurement is the key issue for the monitoring the global warming. Under the agreement between CCT and the WMO, CIMO, the Commission for Instruments and Methods of Observation, we have sent our team as expert to actively participate in the activity of the CIMO, especially measure the temperature and ensure the traceability of the temperature measurement. And on the other hand, we have already invited an expert from WMO to join the activity of working group on environment as well. So it's the action to facilitating the dialogue between CCT, between NMIs and stakeholders. And we set up the task group on emerging technology last year. It's functioned just like a radar to scan the new technology, the technological innovation on the temperature measurement area. With the support of this task group, CCT improved its sensitivity to the technical innovation in the temperature measurement area. In the aspect of the global comparability of measurement, there are 64 countries and economies have the CMC entry in temperature and the humidity area. And we have already developed the efficient CMC review process and a strategic set of key comparisons. For the forward-looking, after redefinition, we foresee a new temperature scale extended a wider range based on the measurements using the primary standards that were used for the determination of Boltzmann constant in the future. And the new technology providing small size and self-calibrated devices will change the thermometry landscape and enable progress, notably in bio and nano science. For conclusion, so number one, it's the time for redefine Kelvin. We have already fulfilled the conditions for the redefinition of Kelvin. And the redefinition of Kelvin will lay the foundation for the future technological innovation. And the second, with the support of the mise en pratique Kelvin, the temperature measurement practice will have no immediate change, and also it will have no immediate impact on the traceability system of the temperature measurement. And the third is we can foresee in the future a new temperature scale, disseminated thermodynamic temperature. And today is the festival for all of us. So for the thermometry community, we are looking forward to seeing the historical moment of the improvement of the revision of ISI. We believe the revision of ISI, and especially the redefinition of Kelvin, will spur technological innovation in the temperature, in the thermometry area, and will change the landscape of thermometry. Thank you for your attention.